Hi, we're going to talk about some special cases of multiplying polynomials. And my first example here is when we have a binomial and we're squaring it, okay? So when I first start out teaching this, I usually say, well, let's just multiply it out so we know how to do it, okay? And so we know that when we're squaring something like 3 squared, it's 3 times 3. So this is saying 5x minus 3 times 5x minus 3. And the mistake some people make is they get tempted. They want to distribute the exponent to here and distribute it to here, and that will not work. Okay, you have to write it out twice. Now, you can FOIL, distribute, whatever you call it. 5x times 5x is 25x squared. 5x minus 3 is negative 15x. You know, I just did that here to here. Another negative 15x here to here is plus 9. Combine like terms. So this right now should not really seem like that much of a special case, except there are some things I'm going to point out to you after I do the next example that are interesting in when you FOIL those out. But right now, when you start off, I think it's best if you just write that twice. So for this one, 3x minus 4 squared, we have 3x minus 4 times 3x minus 4, and then you go ahead and just FOIL it out. All right, now, so for that is what I would do. I would just say, okay, I don't really want to memorize some kind of special trick. I want to just get it right every single time. That didn't take that much longer, and that's probably how I would solve them. Now, I do want to point out to you that there are some elements in your answer here that are interesting. And so you can, if you are that person that you like all the tricks, you can go straight from here to the answer. But there's some things I need to point out to you. So let's look at the first one. What you do is you can square the first, and you can square the second one. Okay, so the first term squared and the second term squared goes here. Then if you multiply that, so that was 5 times negative 3, gets you negative 15. Double it, negative 30. This is actually called, our answer is a perfect square trinomial. Now that we're going to talk a lot more about that coming up, but right now I just want to focus on this. So if we're squaring a binomial, we can write it twice and FOIL it out. Or we can use the shortcut and we can square this. Notice it got to 9x squared. Square this. Negative 4 times negative 4 is positive 16. And then multiply them and double. Okay? So if I was going to do the shortcut here for this guy, I would say, all right, I'm going to square the first one, 4x squared. Square the last one, positive 25. Multiply them. 2x times 5 is 10x. Double it, 20x. Now I even still like to just kind of go back, double check, did I do that right? 2x plus 5, 2x plus 5, 4x squared plus, did I do something wrong? 10x, 10x, 25, I did not do something wrong. Okay, so you notice I get the same answer, all right? Sometimes it's harder to remember the trick because remember in a few months when you do this, it's not going to be, you know, that easy to remember. All right, the next special case is called a difference of squares. And what a difference of squares is when you have the same exact thing in the parentheses, but one is a plus and one is a minus, okay? And so let's start off. Once again, we're going to FOIL it out like normal. We're going to see if we notice anything. So 5 times 5, 5x times 5x, I should say, is 25x squared. 5x times negative 7 negative 35x, positive 35x, minus 49. Okay, so now if you notice here, when I go to combine like terms, and chances are, when you're in a role and you're doing a page, 20 of these things, you might not even notice there are difference of squares. And you might just say, okay, let me just multiply it out. And really a difference of squares is going to be what our answer is. But when we look here, right, we're just going about our normal business, and you'll notice something's going to happen here. Well, if I have a positive 35x minus 35x, that's going to cancel out, and that's going to happen every single time. And so that's what's really nice about these. Okay, so I'm going to get 25x squared minus 49. So that's my answer. Right? Well, if you notice, what is the shortcut here? Well, I could have squared the first term, I should say, and I get this. Square the second term, and I get this. Okay? Now I have to realize that it's going to be a negative because one's a positive and one's a negative. And that's going to happen every single time. So this is why it's called a difference of squares. Difference means it's going to be a subtracting sign, and these are both going to be perfect squares. Now this shortcut is a little more handy for me to remember, a little bit easier to see. All right, so once again, if I don't know the shortcut and I multiply it through, 4x times 4x is 16x squared. Plus 12x minus 12x minus 9. 16x squared, that's going to cancel out, minus 9. Now remember, my shortcut, oh look, this is the exact same thing. One's a minus, one's a plus. So I'm going to square this, and put a subtraction sign. This is a difference of squares. Okay, so now I'm just going to elect to do the shortcut here because I realize they're the same exact thing. So I'm going to square the first one, square the second one, and use a subtracting sign. Okay? All right. The next thing, these aren't really, other cases. It's just these problems were a little bit trickier, and I thought, you know what, let me point it out to you. Okay, so on a case like this, it's just more complex. If you notice here, this is I'm squaring a binomial. So once again, let's say we forgot our shortcut. All right, we would have x minus 4 times x minus 4. And then I have this minus x squared here. So I'm going to hang on for a second. I'm just going to ignore that for a second. And I'm going to FOIL this out. All right, so I get x squared minus 4x plus 16. And then I'm going to bring this down. Equals 176. Okay, so let me combine my like terms. Well, if I look here, I notice that I have an x squared minus an x squared. So boom, that's gone. Now I have minus 4x minus 4x. So I get negative 8x plus 16 equals 176. Well, now I'm going to solve this just like a normal equation. I'm going to subtract 16 from both sides. Whoops, I should have given myself a little more room. 160 divided by negative 8 is negative 20. So I can actually solve this equation by doing this, and I just kind of wanted to show you what happens here with it just being tacked on. Okay? Okay, so now let's look over here. I wanted to put some fractions in because I thought, gosh, when you guys see fractions, you're going to be a little confused on the homework. Same exact thing. All right, 1/3 squared. That means 1/3 times 1/3, which is 1/9. Okay, so when I'm going to write down 1/3 x plus 1/2 times 1/3 x plus 1/2. 1/3 times 1/3 is 1/9 x squared. 1/3 times 1/2 is 1/6. Remember, multiply numerator with numerator, denominator with denominator, x, plus 1/6 x. And I know that these are going to be the same, plus 1/4. Okay, so now I simplify even more. 1/9 x squared plus 2/6 x plus 1/4. All right, so it's really not that bad. It's just I wanted you to see some more complicated answers. Okay, last one. I just heard the bell. So this is going to be a difference of squares. So I'm definitely going to use a shortcut for this one. I square the first guy, so I have 1/9 x squared. Square the second one, 1/4, and I'm going to use a subtracting sign. Okay? All right, good luck. Have a good day.